Hi guys, I hope you're doing absolutely amazing so far. In this video, we'll talk about layouts, which is lazy in nature. Now, when we talk about lazy layouts, the LazyVStack, LazyHStack comes into mind. And we will talk about grids as well. So let's get started. So here I have mentioned the lazy layouts, where we'll talk about the VStack, but it will be the lazy version of it. We'll understand what lazy really means, and we will talk about HStack as well. But again, it's going to be lazy. So lazy is basically something that we have learned in Swift course, where we want things to initiate when we are actually using it. Just like that, if you have views in VStack and you are using, let's say, LazyVStack, and you have thousands of images to show in that vertical stack, only so much of the image that can appear in that particular screen size will be shown or will be loaded. What it basically means, it will not load the rest of the images at all. Only when you actually scroll to look on the other further images is exactly when those images will get loaded in the memory. And this makes the loading of the data efficient, and it increases that performance. And let's take a look at the examples now. So we have the LazyVStack. Let's start with that. I've written a quick definition here. Let's go through that and then we'll talk about the examples. So SwiftUI provides lazy layouts, loading the layouts to improve performance when rendering large amount of data. These layouts only load a view when they are visible, improving the efficiency. So here I have created a structure LazyStack examples, and inside that we are going to load our examples one by one. So starting, and in the preview I'm loading this view, so it will display this one. And here if we jump to this one, which is right here, this is an example of LazyVStack. It's a very simple, straightforward example. So let's go through it. We have a LazyVStack here with some spacing. So spacing will be applied onto the contents of it. The contents will be appearing in a vertical stack since it's a LazyVStack, and the spacing will be provided after every uh, component in it. So we have the text, and this is our component, and we are just printing an item with index, and the index is basically the number from 1 to 100 for which we are running the loop. There will be 100 text inside which we are just displaying the index. I've given some modifiers here to our text. So given a frame, padding, background, corner radius, and I've added on appear, which is going to get triggered or going to get executed when the text will appear. As soon as this appears, it will execute this closure where we are printing the index, and that is it. We have given a padding to our lazy stack. Now, for being the stack to be able to scroll, we have put this all inside a scroll. Very easy, very straightforward, right? So let's run it. I have put this inside lazy stack example, and I have kept this view inside our application. So when we run, our application will load this structure and we'll be able to see it. So let's go to our code and let's wait, and we can see each of our text is appearing here, and you can see item 1. From that it's giving us 12 items although we have 100. Let's see the output, which is going to print our index. So we are seeing the values from 1 to 12, which is our text, and that is what is loaded here, or we can say these are the text which appeared. It doesn't seem in order because it loads the views concurrently. So 4, 10, 12, 8, 9, 2, 11, 7, 1, 5, 6, 3. So it has from 1 to 12, all of it. Now we are loading about 100 text, but it's not really appearing right now. So it's not really getting loaded. If I scroll a little bit, you can see 13 and 14 came up, and a little bit more, so it will give 15, 16 and 17 as well. Although it's not on the screen, only halfway, it will keep it prepared, ready to load. And as soon as you keep scrolling, it will keep telling that 18 just got appeared on the screen. And this is how efficiently the views are actually loaded. It's loaded in the lazy way. And as soon as you just keep scrolling, it will keep loading until you reach the end of it, that is the 100. Once you reach 100, when you scroll down, you will notice 86 is appearing, it's getting loaded. You load more, we loaded 85, 84, 83, and it prints here that these three texts also appeared. And this is the case. This is how lazily our LazyVStack loads the view inside it. And when we talked about VStack, if I remove lazy keyword from here, just a simple VStack inside a scroll view, everything will work. But you will notice how the loading will work. So let's stop and run it once again. And you will see it has loaded all the values beforehand. You can scroll and see from 100 till 1, every text is already ready and loaded. All we have to do is just scroll, and since everything is just loaded, it already has appeared. If you scroll, it's already there, just coming up. And if instead of 100, if it was thousands of images, it will slow down our application. So right now it's just a text, not image, but that too we have thousands, and that too is getting very efficiently loaded. It's M3 chip processing power, so that is helping. So everything's just getting loaded very efficiently right now. But if it was 10,000, it will probably be a very big problem. And we don't want all the 10,000 or thousands of images, if it was images, to get loaded at once. We are only seeing a couple of about 10 items or 10 images. If it were, then why is there a need to load all of them? And that's where we use lazy. So I will undo this and bring back lazy keyword. And that is it. That is how lazy VStack is. So in LazyHStack, it is exactly same as VStack, but the only difference is it's a horizontal stack and it will scroll horizontally. So let's try running it. I will put this in here and let's run this. It is exactly same. It has the onAppear method as well, which is showcasing 1432. So this is our horizontal view. And as soon as we scroll, it will load the 6th, 7th, like that. And we will see these are the views which are appearing, or which are visible. So it will just keep printing until we are done. When we scroll back, it will again showcase that way you are loading 30 right now. So here is the 30. So only those which are visible, those are going to appear. Now let's do one more thing. Just like onAppear, we have on disappear. And inside that, I'm going to print the index and say as disappeared. So when the view goes out of visibility is when on disappear will get triggered. So let's run it. So right now it is loading 1 to 3. When we scroll, it will keep loading, but as soon as I scrolled, 1 and 2 went out of our visibility. You can see 4 is displayed. If you scroll more, the 4 will disappear. 3 is disappeared now, and now the 4 will disappeared. And now 4 has disappeared. So when you scroll, it will tell you that it's loading one by one from the right side, and it's deloading or deinitiating the text view, which is going out of the view. And that is how efficiently what you see is only what is getting loaded by the LazyHStack. As soon as you scroll, it will keep deinitiating or deloading the views which are going out of the visibility or out of the screen, and those which are getting loaded. Now if I will scroll back, you would see it will deallocate 50, 49, 48, 47. At the same time, as soon as it deallocates 50, it loads 45, which is coming from the left side. And that is how the lazy at stake and VStack works. It just same as the stack. It just loads the values of views in a lazy manner. So I have mentioned for lazy VStack that only loads items when they appear on the screen, and they are more efficient than VStack. We have seen how the VStack just loads everything in one go. And it is good for large list when we have thousands of images. For example, we have the photo app of Apple, and that loads the images very efficiently. Now let's talk about lazy at stake. Same efficient horizontal scrolling lazily loads views instead of creating all at once. Now what if right now you're seeing one horizontal stack, right? We can have multiple horizontal stack. For that, we can use multiple lazy edge stack, right? Right after here, we can add another one, correct? But instead of doing that, we have something called grid. Or to be efficient, or to be specific, we have the horizontal grid. We had horizontal stack, which has only one stack. We have horizontal grid, which will have multiple horizontal stack. And they all the stacks will load the view in a lazy manner, and that's why we call it lazy horizontal grid. So just like that, we have lazy vertical grid and lazy horizontal grid. So let's start with taking a look at lazy vertical stack or lazy vertical grid, to be specific. All that happens now, we have seen in the lazy vertical stack, we have one vertical stack. We will have multiple vertical stack now. And you can think of one stack as a column. And just like that, we have to tell how many columns you want in the grid. So let's run our first LazyVGrid. Let's go through the code quickly first. So here, everything is same. We are just using LazyGrid, vertical grid. Here it asks for columns, and here we are just creating a column inside which we have, it's basically an array, and this is the first column information. We just create a lazy item and we just give it a value. It is basically how the size of the first stack or first column is going to be. So we have just flexible right now and some spacing for our values in one or the first column or the first stack, vertical stack. Just like that, I have added two more columns or two more vertical stack. All we are doing is just passing it here, and we are running a loop 50 times, so we will have 50 text in one vertical stack of the grid. So the grid will have three stacks, three vertical stacks, or say three grid items. I call it vertical stacks, it makes more sense. And or say columns, so it has three columns. Each column will have 50 entries or 50 text views. I have my on appear also added here, so it will tell you which view is getting loaded. It is going to load exactly the same how the LazyVStack HStack were loading, and also how they were disappearing or getting deallocated. All we will see here is how the column is going to be utilized. So let's run it first. So you can see three vertical stacks, or we can call it three columns, but you will see the first vertical stack is not getting filled. The first vertical stack, first item is item 1, then the second column was filled, then third, and then again first. So it fills up the columns in this fashion, and you can see from 1 to 3 and so on till 21 is getting loaded, and you can see only from 1 till 21 is getting loaded. As you scroll, the more text views will get loaded. And if I put this up here, I will just copy this up here from here and rerun it. And you will see 1 to 21 loaded right now. The moment I scroll up and just make this one goes out of visibility, you will find first the below loaded, so 22, 23, 24 are loaded. Actually 27, 28, 29, 25, 26, 27, which are just below it, 25, 26, 27 are also loaded. Right now our first, second, third is not disappeared. Let's scroll a little bit up, and as soon as you leave, yeah, and now 3 to 1 disappeared. So it will disappear in this fashion and will also load. So just like I said, lazy is just there to lazily load. And when we talk about V, it's vertical stacks, but we are having the next word is grid. So we'll be having multiple vertical stacks or columns. And I've mentioned it in a note, dynamically adjust columns, lazy loads items for better performance. Just like LazyVGrid, we have LazyHGrid. It will have multiple rows. I will copy this, put this in our structure, and run the application as well. And let's come back to the code. Lazy horizontal grid will have, instead of columns, we will have multiple horizontal stacks. So we call them row. So this is the first row, this is the second row, and this is the third row, and that's all it is asking for here. So let's see this in action, and we can just scroll through it. So this is the first row, the second and third, and that is how it works. It loads again in the lazy way, and that is it. Now let's talk about section and header. Since we have so many information, so many views getting loaded in read, we can create a section for them. So I've mentioned a quick note here, great for displaying content like image carousel, only renders visible items dynamically. Just to summarize, I have here mentioned the lazy layouts we have seen so far and what it is best for. So we started with LazyVStack and HStack, which best for large vertical list or and large horizontal list respectively. And then we saw LazyVGrid HGrid, which are good for grid layouts with flexible rows and grid layout with flexible columns. Now here it's vertical stack, so it should be actually columns and rows. And let's take a quick look at our columns. It is flexible at the moment, so it will adjust according to the view, but we have more options. If you want to make it fixed, we can fix it as well, giving it a minimum of what minimum and how much flexible you can make it. We can make it adaptive as well. As soon as we have another views in the visibility, it will adapt according to the content. Let's say here we have text. If the text is too long and the next view has smaller text, it will give more space to the text with the long text in it. And we'll explore this later. I'm just keeping it flexible for notes right now. And let's talk about section and headers. So here we have two examples. Here I'm just using LazyVStack. And here in the LazyVStack, we are creating, let me just copy this and put this in our view. And let's come back. It's just going to have one stack. What we are focusing on is creating the section, or we can say it's a header. So what I'm doing is a scroll view, LazyVStack, going to just have one vertical stack, and we're running a for loop. And here first we are creating a section. So we have the section here 2D array or a dictionary actually. So this is the key and these are the values. We will take a key here. Since section.keys, we are taking each key one by one and creating a section here. What this section has, a header with a text, and inside that we're just giving which key we are getting, applying some modifiers like font, headline, padding, background color, and that's it. This will create our section and it has a closure inside which what you want to represent in the section. So then we are going through our values. So inside the section we have for loop where we are going inside that particular key, the values, we are fetching each item, creating the text, applying some modifiers to make it look good, and that's it. Let's see this in action. I will run it. And you will see fruit is the key, apple, banana, cherry is are the values, vegetable is another section having these many values, just like that. So this is a vertical stack. It's scrollable as well because I have put vertical stack inside the scrollable or scroll view, and that's it. If we talk about lazy HStack with the section, you will find the code is looking a little bit different than this one because it's a horizontal stack, right? So for every key we are creating the section, and for that we are just creating the heading, and then we are creating another horizontal stack just to showcase them in a vertical stack. Let's see this in action and we'll understand it better. So let's put our lazy at stake in the view and let's run it. Let's get back to the code as well, and you will see it takes the key, and that is how it is showing the text, and then it is showing the vertical stack which is having the values tea, coffee, soda, which is tea, coffee, soda, and that is what we are putting inside a vertical stack here, and that's why it looks vertical. And it is not vertically scrollable, it is only horizontally scrollable since we are using LazyHStack. And that's it. That is all there is. I hope you find this video informative. we have covered the lazy layouts, and we have covered the lazy V and HStack, grids, and section, and how to grade that. And I will see you in the next video.